Hello students, so we have completed question number 1 in our previous video, and today we'll start from question number 2 onward. Okay, let me remind you, we are doing exercise 70, laws of indices. Okay, so let's begin. This is question number 2, simplify. I have copied sub number 1 of question number 2. Okay, we have, let's put this into curly bracket. Okay, first 8x cube can be written as 2x whole cube, isn't it? This cube was only for x here. Now this cube is for both 2 and x, because both 2 and x are within the bracket. So 2 cube means 8 and x cube means x cube. Okay, 8x cube can be written as 2x whole cube divided by, so 125 means 5y. This cube was only for y here. Now let's put this cube all together. 5 cube means 125, y cube means y cube. Now we have 2 upon 3, the power 2 upon 3 outside the curly bracket. Okay, now let's put this 2 upon 3 individually, because this power 2 upon 3 is for both the numbers, this and this, isn't it? Because both the numbers are within the bracket. So 2 upon 3 is for this number also and for this number also. Let's put individually. Okay, 2x cube into 2 upon 3 divided by, this divide sign comes here, 5y cubed into 2 by 3. So this 3 and 3 gets cancelled, and 3 and 3 gets cancelled. So now we have 2x whole square, isn't it? 2x whole square. 3 cancelled, 2 is still there remaining. So 2 square is 4. 2 square means 2 to the 4. X square means x square, isn't it? So this is divided. 5 square means 25 and y square means y square. So this gives us 4x square, divide means upon 25y square. So this is the answer for question number 1 of 2. Okay, this is question number 2. A plus b whole to the power minus 1 into a to the power minus 1 plus b to the power minus 1, isn't it? So I told you earlier in the rules of indices that if a to the power minus 1 is written like this, the power is negative, isn't it? So there is 1 in the denominator. So if you take this number to the denominator, the sign of the power changes. So it becomes, this equals to 1 upon this, a into 1 is a itself, so minus 1 becomes plus 1, isn't it? So this is 1 upon a to the power 1 means a. Are you getting me? Yes. If you change the number from numerator to denominator and from denominator to numerator, actually the sign of the power changes. Okay. Okay, now we have a plus b whole to the power minus 1 means 1 upon a plus b whole to the power plus 1. Plus 1 is no need to write, every number has the power plus 1. If I write 2, you should understand there is 1 in the denominator, there is plus 1 in the front, and there is power 1. Okay, these 3 information should be understood. There is never 0 in the denominator. Even the number 0 is written like this. If this is 0, you should understand there is, 0 has no sign. Okay, there is 1 in the denominator and the power of 0 is 1. Okay, these 2 information should be understood, because if you write 0 here and if there is 0 in the denominator, then 0 upon 0 means undefined, no value. You don't know the value of this number, undefined. undefined, undefined. Okay, so if you write 0 and the power is always 1, there is never the power 0. 0 to the power 0 means undefined. So even if you write 0, you should understand there is 1 in the denominator and the power of that 0 is 1. Okay, I hope you got me. Now let's move on into, this is a to the power minus 1, isn't it? So that means a to the power plus 1. This a to the power minus 1 goes to the denominator, power becomes plus 1. So no need to write plus 1. Every number has power plus 1 if there is not mentioned. So if already a square is mentioned like this, don't say that the power of every number should be plus 1. You cannot say like that. If the power is already mentioned, you should agree with that. If the power is not mentioned, you should understand there is power 1. Okay, Now plus b to the power minus 1 means 1 upon b. 1 upon b. Now we have 1 upon a plus b here. Let us take the LCM of a and b. ab, isn't it? Suppose we have number like this, 2 upon 3 plus 4 upon 5. What we usually do is, if there is number like this and there is no common multiplication table between these two numbers, what we do is, while taking the LCM, we directly multiply these two numbers. 3 5s are 15, isn't it? So 5 2s are 10, we write like this, and 3 4s are 12. This is the way how we add fractional numbers if the denominators do not have common multiple number. Okay, now a and b are totally different numbers, so their LCM will be a into b. Okay, now b into 1, b, plus a into 1 is a. So a plus b, can you see this? This a plus b, this is also a plus b. Though b plus a, 2 plus 3 equals to 5 and 3 plus 2 equals to 5. Either you write in this form or in this form, the result is same, isn't it? Similarly, either you write b plus a or a plus b, the same thing. That means these two numbers are identical and you can cancel them. So 1 is in the numerator and in the denominator ab. So this is the answer for this question. Okay, let's do this question. Question number 3. Before doing this question, let's recall our formula. Suppose we have a square into a cube. What we do is, the bases are same, so we write 2 plus 3, isn't it? When the bases are same and they are multiplied, the powers are added. So basically the power 2 plus 3 means a square into a cube, isn't it? Are you getting me? Yes. So the same thing is going, I am going to apply the same rule here. Okay, 5 to the power n plus 3 means 5 to the power n into 5 cube. So the bases are same, the power will be added n plus 3, like 2 plus 3. Bases are same, powers are added 2 plus 3. Same thing, 5 to the power n, 5 to the power n into 5 to the power 3. The bases are same and there is multiplication sign in between them. The power will be added n plus 3. Are you getting me? I hope so. Now this is 6 into, this is 5 to the power n into 5 to the power 1. 5 to the power n into 5 to the power 1. Needless to write this one, isn't it? If there is no 1 in the power, we should understand there is always 1. So in the denominator you can take this 5 to the power n common. Okay, 5 to the power n is taken common. Common means this number is in both the terms, so this number is taken outside. Now what remains within the bracket? This 9, this 5 to the power n is taken out, minus this 5 to the power n is taken out, 2 square is within the bracket. So 2 square means 4, 2 to the 4. Now from the numerator also 5 to the power n and 5 to the power n can be taken common. 5 to the power n is taken common. Okay, within the bracket remains 5 cube, because 5 to the power n is taken common, 5 cube remains within the bracket, minus this 6 into 5, isn't it? So 6 into 5, 5 to the power n is taken common outside, so 6 into 5 is 30. Okay, 6 into 5 is 30, 6 5s are 30, isn't it? So in the denominator we have 5 to the power n, 9 minus 4 is 5, isn't it? 5. So 5 to the power n and 5 to the power n can be cancelled. Same number in the numerator and denominator, we can cancel them. 5 cube means 125, isn't it? Minus 30 upon 5. Let me continue this here. 125 minus 30, 5 minus 0 is 5. 2 minus 3, oh, 2 cannot be subtracted from 3. 12 minus 3 is 9. This 5 comes here. 5 ones are 5, 5 ones are 5, plus 4, 9, 45, 5 nines are 45. So answer is 19. This is the answer for this question. Question number 3 of 2. 3x square whole to the power minus 3, isn't it? This minus 3 power is for both the numbers 3 and x square. So let's put this minus 3 individually. So this becomes 3 to the power minus 3 into x square into minus 3. Actually 3 and x square both were within the bracket and minus 3 is outside the bracket. This means minus 3 is for both the numbers. So I am just putting this minus 3 power individually. Okay, 3 to the power minus 3 into x square into minus 3 into x to the power 9. Oh, this can be cancelled. 3 1 is 3, 3 3 is 9. So x to the power 3 2 is 6, x to the power 6, isn't it? So 3 to the power minus 3 means 1 upon 3 cube, isn't it? 3 to the power minus 3 means 1 upon 3 cube, because the sign of the power changes if you take the number to the denominator. Are you getting me? Yes. And here x to the power 2 into 3 minus 6 into x to the power plus 6. So this gives us 1 upon, not 1 upon, in the numerator 1 into this means x to the power. So the bases are same. Let's add up the power. X to the power minus 6 plus 6. Bases are same, means power will be added. Into 1 gives the same thing, because a into 1, a into 1, a, 2 into 1, 2, 5 into 1, 5, isn't it? Needless to say, if you multiply any number with 1, you get the same number. So this number into 1, this number. So since the bases are same, the power will get added, minus 6 plus 6. And in the denominator we have 3 cube. 3 cube means 27, isn't it? 3 3 is 9, 9 3 is 27. So x to the power minus 6 plus 6 is 0 upon 27. So x to the power 0 means 1 upon 27. I told you in the rules of indices in the first video that anything to the power 0 is 1. Even u to the power 0 is 1, okay? But 0 to the power 0 is not 1. This is not 1. 0 to the power 0 is not 1. Please remember this. This is the exceptional case. Apart from 0, any number raised to power 0 is 1. So x to the power 0 is 1. Okay, the value of this expression is 1 upon 27. This is the answer. So let's do question number 1 of 3. Okay, evaluate means we are asked to find the value of this expression. Okay, so root under 1 means 1, square of 1 is 1, cube of 1 is 1. Okay, you do whatever you want to do to 1, it will always remain 1. Okay, do whatever the thing you do with 1, unless you multiply with 0, 1 will remain 1. Okay, so root under 1 means 1. Root under 4, this root is for both the numerator and denominator. Okay, so root under 4 means 2. Are you getting me? Root under 1 means 1, root under 4 means 2, root under 1, root under 4. So this root 1 means 1 upon root 4 means root 2 into 2, isn't it? So 1 upon this 2 becomes pair and comes out 1, 2. So this is 1 upon 2. Now we have here 0.01, isn't it? 0.01, there is a decimal point before 2-digit number. That means we must write 1 and put 2 zeros in the denominator. Okay, 1 upon 100, because there is a decimal point before 2-digit number, so 2 zeros. Because there is already 1 in the denominator, every number has 1 in the denominator, I told you earlier. So this number also has 1 in the denominator. So now we have we have decimal point before 2-digit number, so we put 2 zeros after this 1. Now the power is minus 1 by 2, isn't it? Minus 27 means 3 cube. 3 cube means 27, isn't it? 3 3 is 9, 9 3 is 27. Upon 2 upon 3, this 3 and 3 cancels. So this is 1 upon 2. Okay, now plus 1 to the power minus half. 1 to the power minus half means 1. 1 to the power anything is 1. Okay, 1 to the power anything is 1, except, oh, there is no exception here. 1 to the power 0 is also 1. Okay, 1 to the power anything is 1. Keep this in mind, 1 to the power anything is 1. So 1 to the power minus 1 by 2, 1. Okay, so into, now this 100 is in the denominator, 100 to the power minus 1 by 2, isn't it? 100 to the power minus 1 by 2, because this minus 1 by 2 is for both 1 and 100, because both the numbers are within the bracket. 1 is also within the bracket and 100 is also within the bracket. Both the numbers are within the bracket, and this power is minus 1 upon 2. So this power minus 1 upon 2 applies to 1 and as well as to 100. So 1 to the power minus 1 by 2 is 1, isn't it? And 100 to the power minus 1 by 2 is 100 to the power minus 1 by 2. Now if I take this 100 to the numerator, 100 to the power 1 by 2 plus 1 by 2, isn't it? This means this 1 is here and this 100 comes to the numerator. From the denominator it comes to the numerator. Minus 1 by 2 becomes plus 1 by 2. Are you getting me? Yes. Minus 3 square means 9. Okay. So this is half plus 100 means 10 square, isn't it? Into 1 by 2. 10 tens are 100. 100 means 10 square. This 2 and 2 cancels. Minus 9. So 1 by 2 plus 10 to the power 1. 2 cancelled out. So 10 to the power 1 means 10. 10 minus 9 is 1. So half plus 1 is 1 and a half. This is the answer. Half plus 1 is 1 and a half. Don't believe me? You just take the LCM of this and add. You will get the result 1 and a half. Okay. So let's do next question. So we have another question. Question number 2 of 3. 27 upon 8 whole to the power 2 upon 3 minus 1 upon 4 whole to the power minus 2 plus 5 to the power 0, isn't it? So this 27 can be written as 3 and 8 can be written as 2 whole to the power 3, isn't it? Because 3 cube means 27, 3 3s are 27, 2 cube means 2 into 2. Are you getting me? 3 cube means 3 into 3 into 3. 3 3s are 9, 9 3s are 27. This 3 cube means 27. And 2 cube means 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Okay. So this cube is for both the numbers because both the numbers are within the bracket. So 27 upon 8 can be written as 3 upon 2 whole cubed. Now we have the power 2 upon 3 minus, so this is 1 upon 4 whole to the power minus 2, isn't it? 1 upon 4 whole to the power minus 2. If you change the number from the denominator to the numerator and from the numerator to the denominator, what happens? 4 upon 1, isn't it? The sign of the power changes to plus 2. Are you getting me? Yes. Let me explain this. So this is 1 to the power minus 2, 4 to the power minus 2, isn't it? Because 1 and 4 both are within the bracket, so minus 2 power applies to both the numbers. So let's take this 1 to the denominator. So this becomes 1 square, minus power becomes plus power. 4 to the power minus 2 goes to the numerator, 4 square. So this means 4 square upon 1 square, isn't it? So 4 square upon 1 square can be written as 4 upon 1 whole square. This square and this square, 4 upon 1 whole square. The same thing I am going to do here. So 1 upon 4, always you can apply this, always, okay? A upon B minus 3, suppose the power is like this, you can write B upon A whole cube. Number from the denominator comes to the numerator and from number from the numerator goes to the denominator, the sign of the power changes. Okay, this can be applied always. So this means 4 upon 1 whole square, minus 2 becomes plus 2, changes the position of the number changes, plus 5 to the power 0 means 1. I told you earlier, anything to the power 0 is always 1. Okay, a to the power 0 means 1, x to the power 0 means 1, 5 to the power 0 means 1, but 0 to the power 0 means not 1, not 1. 0 to the power 0 is never equal to 1, it is equal to infinity. Okay, 0 to the power 0 is undefined. So now this 3 and this 3 can be cancelled. So this 3 square means 3 3s are 9, 2 square means 2 2s are 4, minus 4 square means 16 plus 1, 1 square means 1, no needless to write this one, isn't it? So this square applies to 4. 4 square means 16. 1 square means 1. So 1 we have already here. 1 upon 1. So let's take the LCM of this number. 4, 1, 1. The LCM will be 4, isn't it? Why am I taking the LCM? I'll take the LCM later. Right now let's copy this 9 by 4 as it is. Minus 16 plus 1 is minus 15, isn't it? Minus 16 plus 1, opposite sign. Minus 16 plus 1, minus 15. Now let's take the LCM. LCM of 4 and 1 is 4. 1 into 9 is 9. Minus 4 into 15. 4 15 is 60. So this gives us 60 minus 9, isn't it? 60 minus 9 is 51. 10 minus 9 is 1. 6 becomes 5 upon 4. The sign of the greater number has minus sign. So the minus comes here. So this is improper fraction if there was no minus sign. Now there is a minus sign, so no need to change into mixed fraction, okay? If there is minus sign, no need to change into mixed fraction. If there is plus sign, then if this was a plus sign, okay, if there was no sign here, now this becomes an improper fraction because the number in the denominator is smaller. In this case, we must change this into either into decimal or into mixed fraction, but we have minus sign here right now, so no need to change. This is the answer. So I hope you got this. Thank you so much for watching this video, and stay tuned, stay happy, stay blessed, keep studying, okay? And don't forget to subscribe and click on the bell icon to get notifications for more videos like this.